interactive maps around marine protected areas or showing what's happening with salmon, rivers, damage to those. There's a whole series of very interesting maps. We have a nice case study on our site about them. So that's Earth Outreach in a whirlwind. Sorry. But some of you I know are NGOs in the room, and there are a variety of ways we can support you. One is just go to our site. It's fantastic. You guys come to our annual workshop, which we call Geo for Good. In some cases, we do work hand in hand to help very big projects get off the ground. So come talk to us afterwards if you'd like. All right, so that's the Maps for Good. This is not Maps for Evil. This is more like Maps for Science, right? All right, so there we were in the Brazilian Amazon, 2008. And a Brazilian scientist came up to me and said, Rebecca, or Rebecca, I think that's what they say. Anyway, we love Earth Engine, or we love Google Earth, we love Google Maps. But the problem is you can just visualize Earth imagery and so on, map data. You can't, the Earth's changing. We're losing 1 million acres of the Amazon rainforest every year to logging, much of which is illegal, happening in remote parts of the Amazon where the law enforcement on the ground is not good. And the science exists, the remote sensing science exists to be able to take daily feeds of satellite data coming in, apply scientific analysis to look at that imagery data, and actually detect areas of suspicious change, and then be able to trigger alerts to people, go check this out, something suspicious is going on. The problem is, it's terabytes of data, or really, if you want to do it globally, it's petabytes of data, billions of megabytes of data coming in every day. And then how do you, if you want to process that data, it could take weeks or months or years on a single computer. So they kind of put the challenge to us. You have the data. You're just letting us look at it. Please let us measure and map trends and change and do science on it. So we're like, so we should do that. So that became Google Earth Engine. And one of the points is there's a lot of satellites out there collecting a lot of data, whether it's atmospheric, terrestrial, ocean. There's a huge amount of fantastic data. Where does it end up often? On tapes. So in the case of the Landsat Data, which is the first major archive we were asked to kind of liberate and bring online and turbocharge, Landsat's an incredible land observing system that has been operating for more than 40 years, systematically collecting a complete picture of the planet every 16 days, and then it repeats. So for every place on Earth, there are 600 or 700 or 800 images over that 40-year period. So you can really, if you put it all together, you could map change over a long period of time. But it's more than 3.5 million scenes. It's petabytes of data. So the U.S. government, NASA, USGS, they get the data, and it goes from the satellites onto tapes in a vault in South Dakota. So it's very secure, which is good. We don't want to lose that data. But it's not that accessible for analysis. So we started a project in 2009 after we built Earth Engine to get that data off tape and into the Google Cloud and make it ready for analysis. So we actually, I don't have time to tell you about the amazing, spectacular technology behind Google Earth Engine, but just understand it's been years in development. It is like an intrinsically parallel, so high performance geospatial analysis system. And we have a data catalog of all kinds of public data, including NOAA data, for example. We're getting NOAA data every day. And then we make available tens of thousands of computers through a very simple to use programming interface that allows you in 1 or 2 lines of code to analyze the entire archive of whatever the data is, something that might take you 10 or 100,000 of lines of code if you tried to build such a thing from scratch, right? And we put it in the hands of the scientific community. We've also played with it over the last year, like, what can we do with this? What are the kinds of things you can do when you have all this data and all this compute power? Well, first of all, there's a lot of clouds in this data, and that makes it difficult for scientists to analyze. So, but if you have enough images over time, the clouds move around, you can typically find a good pixel over a year, for example, and then put together a composite, right? So here's an example. I think this is over Borneo, and this is what we were able to produce. Or take something like this, and with enough images, we produce that. It's like magic. So using this technique last year, I don't know how many of you, I would like to actually, I should do this, find a year-old image of Google Earth and Maps. The global view was really crappy. I mean, it was not cloud-free, there were a lot of problems with it. But we used Earth Engine to process more than 2 million Landsat images and remove all the clouds and produce this global 15-meter cloud-free image base map that's now the base map for Google Earth Maps. The other thing was we wanted to show the Earth changing over time. So we built something called Timelapse that we launched last May, almost a year ago. And the idea is it's a 29-year history of the planet, because the last 29 years are the best data from Landsat. You can go anywhere in the world, and you can see, unlike Google Maps where you zoom in and it's just a static time period, you zoom in anywhere in the world in time-lapse, and it's animating over those 29 years. So for example, if you go into Las Vegas, you see Las Vegas growing while Lake Mead shrinks. Yeah, it's crazy. You see deforestation in the Amazon, you see the retreat of the Columbia Glacier in Alaska, the artificial Palm Islands growing off the coast of Dubai because they wanted to create more beachfront for tourism. It's really, you can get lost exploring it. That's earthengine.google.org/timelapse. But so those are, again, visualizations. The real part of this was we wanted to put it in the hands of scientists, right? We wanted to be able to help stop illegal deforestation, right? Help emerging infection, track and be more proactive in the face of things like emerging infectious disease or drought, or the whole series of societal challenges. So we've now got more than 1,500 scientific institutions, from government to NGO to academic, who are actively using Earth Engine, and they're building data products and services. The first kind of really big one that's come out, the first big result was last November, published in Science. We worked closely with University of Maryland professor Matt Hansen to create the world's first high-resolution map of global forest cover and change over the last 12 years. So that was published in Science. Just to give you an idea, doing that analysis was 20 terapixels of Landsat data. Basically we were running Matt Hansen's models for detecting, classifying forest cover and change. We brought them into Earth Engine. We ran it at scale. It was 1 million hours of computation time, but because we ran it on 10,000 computers in parallel, we had the result in a couple of days. The absolute best case, if you ran it on a single computer that never rebooted or anything, would be that it would take you more than 15 years. So, and that's if it's a 8-core, whatever. I mean, really, it would take you about 300 years. So the point is, this is in your hands now, right? We can apply this for ocean science as well. And I'd love to talk about that with you guys. So what we're also seeing is science, this global scale science and the transparency of this data is now driving policy. The government of Indonesia had been reporting numbers of deforestation that were half of what we reported. And after this came out, it put a pressure on the government, and the president of the country contacted us and said, please work with us to understand the discrepancy between our Ministry of Forestry numbers and your numbers. And we were able to show that these numbers were correct. And they now want to use the system themselves so they can do a better job, right? We also launched with World Resources Institute, this is really exciting to us, Global Forest Watch. So that science product was, we did that last November. We're going to update it annually. With Global Forest Watch, Earth Engine is powering an every 16-day alerting system for the forests of the world. And this is now being put in the hands of not just civil society and so on, but actually companies that are sourcing commodities from rainforest areas of the world. Some